The ordinary least squares estimate for a simple regression model. This is why I'm on Agrawal. Anyway, simple regression. In econometrics, a simple regression tool is used to establish a relationship between two variables. One of the variables, big Y, is called the dependent variable or the regressand, and the other variable, big X, is called the independent variable or the regressor. Mathematically, a simple regression model is expressed as big Y sub I equals alpha plus beta big X sub I plus epsilon sub I. Here, alpha and beta are the regression coefficients, i.e. the parameters that need to be calculated to understand the relation between big Y and big X. I has been subscripted along with big X and big Y to indicate that we are referring to a particular observation, a particular value associated with big X and big Y. Epsilon sub I is the error term associated with each observation, estimating alpha and beta. So how do we estimate alpha and beta? One of the most common approach used by statisticians is the ordinary least squares approach. The OLS stands for ordinary least squares. Under this method, we try to find a linear function that minimizes the sum of the squares of the difference between the true value of big Y and the predicted value of big Y. Let the true value of big Y associated with each observation be big Y sub I, and the value predicted by our model be alpha plus beta big X sub I. So we're essentially trying to minimize the sum from I equals 1 to n of big Y sub I minus alpha minus beta times big X sub I. And we close the parentheses and we square it. Where I goes from I to n indicates that we have n observations for our data set for values of big X and big Y. And notice I didn't say open parentheses after the summation. Graphs can be more intuitive. So, derivation. Now we know that ordinary least squares, what it is and what it attempts to do. We can begin our derivation for estimates of alpha and beta. Step 1, defining the ordinary least squares function. Ordinary least squares, as described earlier, is a function of alpha and beta. So our function can be expressed as f of alpha and beta equals the sum from I equals 1 to n of open parentheses big Y sub I minus alpha minus beta big X sub I close parentheses squared. Step 2, minimizing our function by taking partial derivatives and equating them to 0. First, we take the partial derivative of f of a alpha and beta with respect to alpha, and equate the derivative to 0 to minimize the function over alpha. Partial derivative of f of alpha and beta with respect to alpha is equal to 0. Therefore, the partial derivative of the sum of I equals 1 to n of big Y sub I minus alpha minus beta big X sub I squared over alpha is equal to 0. So the negative 2 comes out. Well, the 2 is from the squared when you take the derivative. So you have negative 2 sigma, which is the sum of from I equals 1 to n of open parentheses big Y sub I minus alpha hat minus beta hat big X sub I. And that equals to 0. Since negative 2 is a constant, that just falls away. And we're left with the sum from I equals 1 to n of open parentheses big Y sub I minus alpha hat minus beta hat big X sub I equals 0.